So thank you so much for being here and coming to this talk. Let's go ahead and get started. So first off, who am I? Well, simply put, my name is Brandon. I love Ruby, and I'm here to share a little bit of that with you today. Now, I've been programming Ruby since roughly 2004 with RPG Maker XP. It turns out the entire scripting engine was actually Ruby in that. I didn't know until a decade later, but here we are. And several companies thereafter, from an ISP to Cerner to PlayStation to Square to Gusto, and finally thereabouts to Amazon, where I work under the healthcare division in One Medical, focused on provider experience as far as cost of care and making it to where they can serve patients more actively. Now, do note my words are my own, and I'm here today as myself, speaking independently. But there is one note before we get started here. Now, several AI tools rely on an active internet connection. I, by fundamentals, do not trust conference Wi-Fi. So we're going to be replaying these interactions through slides instead of using the direct AI to ensure that all content can be covered without any fun and interesting surprises of me trying to debug live on stage, which you don't want to see. Well, you might want to see. I don't want to see. Okay? There. So we'll be showing some code segments, but I'm going to be heavily aligning them for slides because there's a lot in here, and I want to make sure that we can focus on the overall concepts instead of getting into the true weeds here. So that said, shall we go ahead and get started? So section 0, introduction. So we have a problem, and you might be familiar with this. Let's say you have a brand new developer, never used Rails. What do you suppose happens whenever they open up one of these giant monolithic code bases? Packages? Packwork? Are any of these docs updated, maybe preferably this decade? Where do you even begin to start? And that's a very good question, a very hard one, in fact, and there have been books and talks and who knows how much effort around what do we even do here. So traditionally, you would read the docs, you'd ask your teammates, and probably spend, the next 2 to 3 months ramping up and starting to get comfortable with where things are at and how they might work. The bigger the application and the more sensitive the domain, such as payroll, healthcare, legal, or anything else like that, this can take even potentially much longer than that. But the docs are out of date. Your teammates are probably busy on their own projects. The Slack channels for asking questions have changed hands so many times, we don't know who owns them or if they're even still live anymore. And those 2 or 3 months start feeling really long and really lonely as you're trying to figure out your way and getting more and more lost while you're doing it. You might not even know Ruby. You might not even know Rails. Why teams end up using Packwork for modularity, any of it. You have zero context. So does that sound familiar to anyone? Struck a nerve? Uh-huh. So show of hands real quick. How many of your code bases have, say, 50 models? Okay, let's go up to 100. Keep them up. 300. 500. Okay, let's try for over 1,000. I feel your pain deep in my heart, and I'm so sorry. So of those folks with 500 plus, how many of you know every bit of code your team owns? Me either. I'll be honest, I don't. I definitely don't. Right, after a while, it gets difficult to keep track anymore. There's so much to maintain, and as someone who knows a code base, you're still lost. Imagine someone brand new, their first week on the job, going into that exact same thing with no context, no network, no connections, and no idea where in the world to even start. End of the day, we've all been there, myself included. Introduced to a giant code base we don't know the first thing about, and feeling completely out of your depth as you attempt to remedy that. There has to be a better way to manage this. Now, as I'm in San Francisco, I am obligated by duty to say, what if AI? There are no executives in the room, so I'm probably safe. So perhaps it could tell us about the data models owned by what team. Perhaps it could tell us about the blast radius of a change we're about to make. Maybe it could suggest where the code happens to live. Or it could explain all the coupling which exists in our application. And maybe it can even tell us what happens when you go to a certain endpoint. There's a lot it could be doing in here. Now, that's where MCP tools comes in. Think of MCP, which is Model Context Protocol, as a way of giving AI a set of specialized tools for your Rails application. How does it work? How do you get information? What can I pass to it to get better information here? So querying your pack structure, analyzing dependencies, search your specific code base, understanding your team's conventions. Instead of generic AI advice, which may or may not be applicable to you, you get answers about your system using tools that already exist inside Rails, because Rails has a wonderful amount of introspective logic in it. So what exactly does an MCP tool look like in Ruby? We're just going to briefly go over this. A very basic tool might look like this. And we make a tool, we make a server, we register the tool, and then we start it. Now, if we save that as hello MCP and made it executable, we could add it to any of our AI agents that happen to be in our editor, such as Klein, Clo. You know, there are so many tools, I just get lost. I'm not even going to try. There are a lot of them. And by the time this talk is done, there will probably be 5 more. But for my case, I use Q, so that's what I'm going to be going with. So it's going to be similar to Klein and other options, though I do personally prefer the command line interfaces. Now, say we wanted to add that tool, though. We could configure MCP tools through the option label configure MCP server in the menu bar. Inside of that, we could add a new MCP. And we can choose to make that global, which if it's local context doesn't make much sense, or we can make it local. For our use case, we want it to be local on a standard I/O, but some HTTP ones do exist, and you will end up using those. I'll mention some of those later in the talk. So let's just say it's hello MCP for now. We give it that command of ./hellomcp.rb. We don't really need environment variables. Timeout's fine for default, so we can go ahead and click save. Now, this is an interesting one, is that AI does try and at least be polite and ask you first before it goes and does things, most of the time, unless you have production databases. Don't do that. Don't tell it git exists either. So will you give it permission? Will you have it ask, always reject, or maybe you always allow? For me, personally, I tend to err on the side of always allow if it is a read-only command that doesn't change things. I've done that the opposite way with write commands. Don't do it. Bad idea. Lots of fun stories and experiences. Find me later for those ones. For read commands, again, always allow, but for anything else, I personally prefer ask. Now, if we press X, we can go back to the interface and say use the hello tool, which is a little on the nose, sure, but the more useful the tool names, the more useful the descriptions and arguments for them, the more AI can automatically infer what you probably meant to use and figure that out. So we get an option to run it. We can click run. And then we get back a hello world message. Now, one thing about that click to run thing is you can look at it and say, yes, that is exactly what I want, or no, you got a couple things wrong. That's why I do prefer allow in some of these cases, especially for write things of, let's correct this, make sure it's on the same page. So hello world is great and all, but that just gives us the introduction. What if we had our own MCP tools instead? Ones that can leverage Rails internals around model, controller, route, and other introspections. Maybe even ones which happen to understand Packwerk and how that happens to work. Really, we could do a lot here. And this talk is going to lead with what those interactions look like before diving into too much of the code itself. So why might this matter? Well, we have a project we've cooked up for this presentation. And that would be a Packwerkified fork of Mastodon. Now, I'll get to those terms in a second, I promise. For the sake of this example, we'll say that somehow there's a full company around Mastodon, and our new Rails developer just happens to have gotten hired. And our new Rails developer is unfortunately a Python developer. We don't judge, we welcome all types, but they don't know the first thing about Rails. So briefly though, what is Mastodon? What is Packwerk? Why should you care? Mastodon, massive social network, it runs Rails. Packwerk, well, let's say you start a new Rails application, you have your model view controller folder. Everything is in one giant pile in there. Eventually you start getting annoyed at that pile and say, I have something which looks like a user. I have something which looks like auth in. I have something which looks like social network features. So you start organizing them by function rather than that. And eventually you start getting a lot of people. And when you get a lot of people, you have a lot of teams. And when you get a lot of teams, you get a lot of organizations. So you start saying, maybe we group these by team and then subgroup them by organization so I know what code I particularly own. That's where Packwerk comes in. Whenever you start seeing 100+ models of how in the world do you reason about who owns what dependencies are there, how do these systems interconnect, and who is using code they're not supposed to. That's where Packwerk comes in, just for context. So it can keep track of things such as circular dependencies, metadata about teams, including Slack channels, which thankfully you can audit and make sure those are correct, and violations where one API or one pack is using the private code of another pack, and it helps you understand how that code base is connected. Now, for those of you who know Mastodon or have looked at this code, you'll know it's not a Packwork repository. You would be correct. In fact, I don't think there are really any large open source Rails apps that do that. I'm happy to be proven wrong, by the way. This takes a lot of time to do. So perhaps the strategy is just to make our own. That's kind of what we did here today. I had Q do that over the course of about 4 or 5 hours and watching a lot of things on YouTube. Turns out checklists and breaking things into tasks really help with getting this done, except for that perpetual last 2 to 3%, which is cursed no matter what you do. Now, what it did do, however, you might think, well, I can just run Q or any AI tool on this and get a fully Packwerkified modularized code base. No, not really. It created a bunch of junk drawers, a bunch of coupling, a bunch of other terrifying things in there, which I am loath to mention to you lest I scare you out and you run out of this room screaming. That is not great if I want to live in that code base, if I want to maintain it, but it is great if I want to make a talk about fixing said things. So see, it worked out. So let's get started with some basics on understanding the code base. Let's say we wanted to know, for instance, the names of all the teams in our code base. What if there were a tool which happened to understand Packwork and was able to intelligently give you some references on that? Perhaps the tool could query for, say, pack ownership. The tool leveraged like Query Packwork, a gem I developed back in my time at Gusto for introspecting Packwork and relationships and violations and packages, and you could probably find out some of this information. You can find that open source at Ruby at scale. So the implementation underlying it might look a little bit something like this, where we get all the packages, and maybe we want to know about the count of those and some basic information about the dependency names and the count of violations. Now, MCP sounds scary, but honestly, it's just how do I get structured data into AI that it can do something with? JSON, YAML, CSV, what was that new thing, Tune? Anyway, lots of things. As long as you get information AI, that's a goal here. Now, after that call, the MCP server will respond with some data about what packs exist, who own them, and how many violations it might happen to have. And if we scope into that, we can see that there happen to be 11. So 11 teams, 28 packs, and that gives us something to start with, but we care about the code we own. That gives us overall structure. So what if we, say, work on the platform team? We want to know what code our team owns. AI should be able to figure that out with us by giving some detailed information using another tool over here. Now, same tool, different arguments to get packages owned by the platform team. In this case, the code underneath it is doing something a little bit more like this, where we're trying to find what packages are owned by that particular owner. So that tool will run, we give it a little bit of time, and then it will say our team happens to own 8 packages with a total of 18 violations. Now, you remember we had 28 packs. That's a lot for a team. So we have core infrastructure, a lot of API layers, even web UI. We also happen to have federation code and FASP and a lot of things I don't really know about. And then we also have a platform and a search and a timeline and even an integration into webhooks. And this sounds like a lot for one team, doesn't it? I think we probably have too many packs in here, but we can get into that a little bit later. So the point is, we own a lot on this theoretical, hypothetical platform team. And that means a lot of code to figure out, but we have to start somewhere. So how about we ask something like, say, what data models do we own? For me, data is always the foundational place to start with, which is what are the underpinnings of our application? What runs it? AI can take that, and it can actually give us back exactly that with another tool that knows about models and it knows about ownership. Now, this tool can look at all the Rails models that happen to be owned by the platform team by combining Rails introspection with Packwork ownership knowledge. So what that might look like is we have something in there which will ensure that our models are loaded. We find models by package, and I'll get into that in a second. We limit it, assuming that we have a limit on there. And then we turn back how many models there were and how many we happen to find underneath there. And of course, these are simplified examples. The true version is a little bit longer, but again, slides, short, so we work. So personally, I'm not entirely convinced by this implementation, but for the moment, it works by constantizing file paths. I also may have vibe coded some of this, don't judge. So given that all the models are eager loaded, I believe this may get updated soon. But the idea is we want to find packages where we have ownership, and then we want to find all the models under those packages, and we want to load those classes. That way we have reference to them. So given that information, AI can summarize that information about those models, and it can tell us something like, say, we have 21 data models. So we have some categories matching up to what we saw earlier with the pack ownership around federation and instance management, webhooks, user settings preferences, content and metadata, web UI, FAST, and a lot of stuff. And it will even give us a little bit of summary. AI loves summaries. Thankfully, I mostly love AI summaries until I don't, and then I tell it, please stop. But we need to go a little bit deeper. So let's say we want to know about a particular model. Like, let's say we want to know about the instance, which is a single instance, like, let's say, ruby.social or hackyderma.io, for instance, might be a Mastodon instance. AI could do just that and get us some detailed information about the model. It's nice to know the names, but we kind of want to know a little bit more about that. A tool that's aware of filtering to an exact model and getting detailed information about it. When getting multiple models, we only really wanted a high-level overview, but if we're getting into the weeds, we also want such things as, say, attributes, relationships, scopes, methods, and more interesting information, which gives us something that we can actually dig into here. So what this might look like is going into application record descendants, which is basically anything which happens to be active record, and then taking out any abstract classes. We want real models, preferably. And then we want to do a fuzzy find, because I typo everything, and thankfully you can use some short little string distance things to make sure you get something approximately there. So that's going to find that, get us detailed model information, which might look a little bit something like this, which might give us a model name, the table name, what columns we have, what types they are, what associations we have, and what they happen to map to. You could potentially give more information here if you so wanted, but it's going to be kind of a dial of how much is useful versus how much is overkill here. So now AI will probably want to read that file as well, because AI loves double checking itself, which will then lead to another call. In this case, it's a built-in tool, which is file read, so we don't need to go over that. But it will give us some detailed information about this model, as well as some information about its purpose, such as it represents federated Mastodon instances in the network. That's a lot of words. Most of those don't mean anything to people. Trust me, that it's very important, impressive stuff. Now, it's a database view. That's an interesting thing, which is that this is a materialized view. This isn't an actual model. I didn't know that whenever I started this. I didn't know anything about the Mastodon codebase or what it did. So I'm learning along with you all. But it'll tell us that it's a database view, which happens to have a primary key of domain, which happens to be a string, which is interesting, which is the domain name of the instance, as well as it happens to have a cached accounts count over there. It also has several associations such as domain blocking, what happens to be unavailable, what accounts happen to be there, what moderation happens to be there. But that gives me a question, which is, why is there a whole bunch of moderation stuff inside of the idea of an instance? That might be another pack, but we can get back to that. So it does have some features around moderation, but also availability and search features and a lot more. There's a lot in here, and this is the type of information which is useful, which is what exactly am I dealing with? So for instance, it might have a bunch of scopes, which are going to be not too exciting over there as far as searching things, getting domain names and subdomains, and what domain follows what, and a few status methods, as well as where that code actually happens to be. But I think probably the most useful one, if I'm ever getting an application, is I don't know the data models. I don't know anything else. I just know that someone showed me a production page with a URL and said, here's what it does. Go figure out how to change this thing on this page. I don't know the first thing about that page, or what models are there, or what controllers are there. So what if I happen to ask it about API v1 instance, which happens to be one of those methods? Now, AI can actually do some of that too if we happen to give it the right information. So this might give us something like, say, we have a tool for tracing requests, which gives it a URL and also gives it include nested, which is what if there are resources underneath this? Now, the underlying code for this is a lot more involved than we're going off of, but we're going to lie to make more out of it. So we start out by finding the routes and then getting more detailed information about them. As far as routes, Rails does actually expose that, and Rails application routes. There's probably a reason for routes. I don't know it, but that amuses me every time I have to type it. So the first thing is we want to find the exact route that we happen to be looking for, and then we want to find all resources which happen to be underneath it if we happen to have nested as an attribute. And then we want to limit that preferably by a reasonable amount if we happen to give a limit. Then it's going to go about getting more data in there, such as what's a controller name? Routes have access to that. What's action name? Is it show? Is it index? Is it new? Is it create? Is it what? And then it's going to be able to get that actual controller class, and inside there, the method that it happens to be and the file path. Now, based off of that information, you can make other inferences, such as what's a high-level information about the route? What's information about the controller? What models happen to be referenced in this? Where's the view? Who owns this thing and where exactly is the source code? I'm not going to dive into every single one of these, but you can get a lot of information off of just a URL, which is probably going to be the entry point for most people. So given that, AI can take a look into it, and it can tell us what exactly happens on that route. For instance, it can tell us that the controller happens to be a show action. It happens to be at the instance controller on line 8. The action happens to be right there. And it has something interesting there, which is it's been deprecated since 2022. So maybe different example URL next time. Underneath it, though, we can also see what the nested resources are, such as getting the peers, rules, domain blocks, privacy policy, terms of service, everything else there. Now, again, most of this information doesn't mean anything to me included, but it's interesting to be able to see what exactly is in there. And it's also interesting to see that all the endpoints are heavily cached and owned by the platform team, so our responsibility. But that's getting a lot of information. What if we want to know about potentially making changes? Like, for instance, if we were to say, want to know what happens if we change that instance model, what might be impacted by that? Well, perhaps AI can give us a measure of blast radius of that change, or at least make a fairly reasonable guess as to what might happen. So it starts out with a direct code search. And that's something to remember about AI is it's not the best about always using the tools you intend. So sometimes you have to force it and say, no, I really want that tool. Please use that tool. I need you to use that tool. And then it goes and ignores you again. Anyway, that's when you restart the agent. And even if you type the same thing 10 times, you might get 10 subtly different answers, but you're still getting information here. And the interesting part is whenever AI starts to use all these tools in conjunction. So we'll get into that in a second as well. But oftentimes it does find its way back to the tool we want, like this one catered towards measuring the impact of changing a class. Now, as with routes, this one can be involved, so we'll align a decent amount here. The search tool is a thin wrapper for ripgrep, which is a faster version of find because AI loves using find for some reason. It's horrifically slow whenever you have a million-plus line of code monolith. So the rest involves figuring out what files were impacted and stitching that together with Packwerk violations. And we might have a lot of information here, such as how many files match, how many files are affected, what packs are affected, what teams are affected. Maybe we want to know about cross-team impact as far as how many teams are going to be involved in this as soon as I open this up for PR. How many coordinations do we have to have? What's the risk level, which is a heuristic based on how many matches, packs, or involved teams there happen to be. And then maybe we happen to have Packwerk violations to break down that information by pack. If we feed that information into AI, we can get an idea of what exactly is going on there. But what's interesting is AI decides to use multiple tools here. And again, the real power is whenever these tools are used in conjunction, AI is able to make the glue between all these disparate things to make something very interesting. The next tool is looking for violation information based on Packwerk violations between packs, but it's only going to find a few because, again, this was a very quick job of Packwerkifying this thing. So simplifying what it does, it's looking for the constant name and is getting anonymous source counts. And what that means is what does the code look like on the caller? We don't care about the arguments, which is why you have underscores there. We just care about the general shape and then how many of those instances happen to be found. At previous code bases, there might have been 50 to 100 of those things, which makes a real clear case for that's probably a public API, isn't it? And that's what method we're calling on it. So this can give some insight into how others are using or misusing code from your packs. But AI still has more tools, and frequently it finds its way back to file read, so it wants to go and read that model and is going to insist on that. So then it wraps up its tool calls with searching for the instance, but with a dot after it, which is likely trying to catch invocations such as instance dot method name or something like that. Not entirely sure why it's limiting to 30 if we want the true blast radius, which is why you always want it to probably be asked on tools to say, no, I don't want 30, I want 100, I want 1,000. That way you can adjust those things in flight. But that's why you keep an eye on commands and don't always necessarily approve them. Now, as mentioned earlier, the search tool is a wrapper around ripgrep, which is much faster than find, but it'll fall back to grep if needed. For now, only worry about the fact this is a faster way to search code, and the original version wanted to do a Ruby file parse, which no, I don't have time for that. So we run the command, find the results, format them, and back off to the MCP it goes as far as what file, line, and content, and what matches do we happen to get, and how many of them did there happen to be, which brings us back to the next step of what it happened to find. Now, it looks like it found a lot of things that rely on us. I wonder what they all are. So it has database view dependencies, which is backed by a DB view in there. It happens to have view of aggregated information. It happens to have API endpoints, which are referenced in there, and it happens to be on both the V1 and the V2, which will break things over there. It also happens to have a lot of associations, a lot of administrative features, and we have additional confirmation about moderation running through there. Now, again, there seems to be a lot of moderation, a lot of unrelated logic in here. Scopes and queries can be a real hassle when breaking things down, especially for those who use other packs heavily. Active can be a blessing when starting out, but the bigger you get, the more that starts to become a little bit of a curse as far as you have everything deeply entangled with each other and you can't really understand it. We've also got background jobs doing some refreshes, instance checks, existence checks, and other things. Metrics analysis, and I am brushing through this very quickly because a little bit too long here. And search again for indexing. Ideally, as an application matures, the number drops like a rock as far as how many teams are involved in making any changes to anything. But the higher cross-team coordination, the more likely it is to happen. So one thing is AI loves summaries. Sometimes I need to tell it to love them less, but it does give me good brief information at the very end of whatever in the world it happened to spit out. And most of the time, I'm only paying attention to that part. In this case, it reflects a lot of what we've seen here. And it gives us a recommendation of test changes thoroughly through there, especially serializers, presented API controllers, and consider feature flagging, which is actually a very nifty concept it has in there. If you're in a big monolith, feature flags, best friend, use them, live by them. It will save you so many times. So where exactly is this instance presenter used, for instance, which we happen to reference in there? We can use that search tool again, which is going to go and look into here for any of those instances. We can find it's used in 11 places around API controllers, web UI platform teams, admin team, shared utilities. We can even get the definition test and some of the key areas that we want to pay attention to. Now, if there are enough of these, it certainly saves me the time of a straight code search, especially the ownership information, but with all things in AI, verify twice. Now that said, we can go a little bit further here. What if we happen to want to analyze the architecture of that giant shared pack, which by the way has about 1,000 files if I remember right. Pre-AI, that probably would take me the better part of 2 or 3 weeks to go and research that, put it in a whole bunch of spreadsheets, tables, everything else. I got code citations, all that 9 yards. And I just really don't have time for that. So what if AI could research that for us? The real problem is we have, after the initial packification, there's some 1,000+ files in that shared directory, and some of those are very likely to have much better homes where they'll get better attention. But how do you know that? Well, in the days of yore, you'd have to go through, hunt every constant reference, and make best guesses on where something should go. Clever folks even had some heuristics around this. So let's see what AI can do about this. We can tell it, there's a lot of files in here. You should probably do something about it. And it'll say, yeah, let's go ahead and analyze that. Now, we can wrap this heuristic around constants and ownership information into a tool to get a good idea. Now, given the length of this tool, we'll err on the side of explaining how it works. For each file in a pack, it reads the file, looks at the constants which happen to be referenced inside of it, finds out who owns those constants, and if enough are owned by a different pack, there's a really good chance that it should probably be nearer to that pack than the pack that it's currently in. Now, from here, AI can help us make some of those breaks by suggesting where we should happen to start. And remember, this has a limit because pagination and you will blow the context really dang fast. So high confidence moves, it might say something such as, hey, there are a bunch of things with accounts in here, and maybe an LD helper. Maybe there's some stuff around content filtering or content teams that we happen to have in here. Maybe these should go into the moderation pack. Maybe these should go into authorization. And the rest look fairly reasonable. You could use this to even make a checklist and say, okay, AI, go fix that for me. I'm not going to get into that part, but you very easily could. Now, with these types of packs, it's never easy. Out of some 900 plus, we've only identified 14 out of our 100 limit. We can, of course, paginate this, and I did, to ensure that things like specs and related files are also batched with them. But if we run it on the entire thing, it actually gets, interestingly, about 404 out of the 975 and finds a lot of information about where that should go. Though, really, you want to scope out sometimes to see the broader picture, like what relates to what circular dependencies are there, where is the coupling, and maybe let's put a mermaid chart in there for fine details, which is really useful, by the way. It's very good at doing that. So it will go ahead and take a look at that and find out what it can give us. So in this case, it'd be really handy to have a tool which collects all this information about pack work together, such as the previous examples, and also a very complex tool, so again, high level. We want to find circular dependencies where packs eventually depend on themselves through some sort of indirection. We want a view of how many packs have high coupling and see how often they violate each other and how many packages happen to be present, which gives us back something fairly useful over here. Now, sometimes AI can pull back recent memories, like in this case, it was done in the same session where I asked it what teams there were, so it's going to pull from that reference and then give me a complete picture of what exactly we have in here. So we have 28 packs, 12 of them have circular dependency, which is about half, that's not great. 6 have coupling issues. We have a lot of intertwinedness from the social team and the platform team and the moderation team and all this other stuff, but those are insights I might not have had before. And then it'll tell us about circular dependencies, where admin eventually depends on admin through a couple of areas. Platform eventually returns onto platform, and a lot of those in there. Or maybe we have pack level of what exactly those happen to have, high level coupling or other things. And the key issue, it'll actually pull out some of this synthesized data into, we have 5 or 6 circular dependencies making a major coupling point. Now, I am not going to try and zoom that in, except to say it's very impressive that it spat out something which looks mostly reasonable, though I question its color design there. But what we want in there is the key findings, such as federation is a bottleneck with 5 or 6 circular dependencies, high-level teams, APIs with 22 other packages, making it highly coupled, platform team, and it gives us a critical insight here, which is it's a hub and spoke pattern with federation API being the central hubs, but there's a lot in there which probably shouldn't be. So that gets us to reflections and insights. So the thing about MCP tools for me is I like a few concentrated tools rather than many small ones to keep AI focused. We've used about 6 tools in this talk that you might have caught so far, such as the query packwork tool, which can get us ideas of packages, violations, who owns what patterns happen to exist in the code base, who consumes packs, who produces the APIs which packs are consuming, getting a graph view of that, or maybe even suggestions on what we should be refactoring. There's also introspect Rails, which uses a lot of the Rails internals, such as models, controls, jobs, routes, everything. Rails has a lot of reflections, a lot of data on this. Trace request tool, which is how do we take a URL and figure out what controller, action, model, view, owner, and everything so you happen to have in that with full request view context. Measure impact tool, files, packs, teams affected, cross-team coordination requirements if you make that change, pack violations, risk assessments, and sample files by pack. Search code, again, simple thing around ripgrep, but it does do a good job. Suggest pack move tool, which is where should I put all those files from that junk drawer? So beyond code, there are more MCPs around there, such as GitHub has one for PRs, reviews, issues, Jira for your tickets, your descriptions, maybe your epics, maybe to see what exactly is blocking what someone's getting stalled on, coordinate that with the PR to see what comments are in there and see what you could do to fix that. Maybe you have Confluence for your wiki information, your architecture, your process guidelines, your architectural decision records, whatever have you. Slack maybe because you're trying to search for where exactly you can find that, and someone thankfully has said 2 weeks ago the exact issue you had with OpenSSL because Brew just did an update again. I love Homebrew, they're great folks, but every time I see OpenSSL upgrading, I fear for my life slightly. Maybe you have PagerDuty in there for incidents and rotations. The actual value we get out of here is things such as, what does my team own? You can get that answer in a couple of seconds instead of 20 minutes. Where is this thing used? You don't have to grep around anymore, it goes and figures it out. What breaks if I change this? Now you know who teams you're probably going to likely have to talk to and get on your good side before you do that type of stuff. What exactly is blocking my sprint? Find the deployment docs, what do we need to know about it? For onboarding, instead of 3 months to understand the code base and tools, maybe we could have that be in about 2 to 3 weeks, be immediately productive, have people able to onboard enough to where they can make informed decisions about this. Now that said, still review the code, of course, but that gives us a lot of information we might not have had. So for me, the value here is less context switching between tools. I can just ask questions and have semi-reasonable answers, which will get me where I need to go. So the tools, it'd be nice if those would be open source and everyone could access them and everyone could use them immediately. To that I say eventually, maybe. I may have vibe coded a lot of this stuff, so I'm going to clean it up first, add some of the nice things I want to add, and I will be looking to open source it. But again, with Amazon, I do need to be careful about some of that stuff, so I'm going to do it through the right channels. As time allows, which it doesn't, I'm sorry, but we're not doing live demo and Q&A. If you happen to ask me later, though, I can demonstrate some of this to show you that it does actually work and it doesn't blow up and I'm not faking things. So, wrapping up. Thank you so much for your time. You can find me on the various social networks. I am everywhere. There are probably a few more because like AI tools, there's always a new social network. And that is all I have for today. So thank you so much for your time.